Okay, so derivatives of trig functions. It's a function, has a derivative. Okay, so the first part, the little first paragraph, don't really worry about it. It's just kind of saying to find the derivative. What do we do to find the derivative of sine? I think the easier way is just by looking at the picture. All right? This is the sine wave, the sine curve. Sine wave, sine curve, one rotation, one cycle of it, right? Because it keeps going and going the same direction forever and ever and ever. Okay, so one cycle of it, right? Because it repeats after that. So what is a derivative? What were the three words again that I told you guys every time you see the word derivative you should think about?
Slope, tangent line.
Slope, tangent line, right? It's a slope. What is the derivative? It's a slope. What is the slope of? A tangent. Okay, it's the slope of the tangent line. So remember, tangent means hit something at one spot. It's a line that hits something at one spot, only one spot. So like tangent at that point. Tangent at that point, right? That's what it is. So what we're going to do is we're going to find slopes along the dotted line. Okay? We're going to find slopes. We're going to find as many as we can. The easiest place to start is where slope is 0. So what is, if I have a slope of 0, what does that look like? What does a line with a slope of 0 look like? How does it look like? There you go. Flat, horizontal, right? So the easiest place to start is where the tangent line would be, have a slope of 0, flat. So along this dotted line, right, from dot to dot, where would we have a slope, or where would the tangent line look like that? I'll give you a hint. There's two spots. There's two spots from 0 to 2 pi, where the slope, where if I were to hit the graph, right, because the graph is, let me highlight it. This is the part I'm looking at here. Right? So where would the two spots be that if I were to come in contact with it, it would be flat? So 1 and -1. So you're talking about here? So 1, oops. So over here and over here, right, I don't even come in contact with the graph. So it has to be somewhere where I come in contact with the graph. I kind of see what you're saying. What's the x value, though? I think you're thinking y value. What's the x value? Think of the x value. What x value?
Pi over 2.
There you go. Yeah, there you go. At pi over 2, where does it come in contact? It comes in contact right here, right? So let me make a dot. If I were to go through that line and hit the yellow only in 1, it wouldn't look like this. That's not a tangent. That's a secant, right? If I go through it, it's a secant. Go through the yellow. I don't want to go through the yellow. I just want to graze the yellow. So that would look like that. What slope does that red line have? What rise over run does that red line have? 0, right? No rise. No rise means 0. So at that red dot, I have a derivative of 0 because of that. Okay? So let's go down to our table here. That has an x value of pi over 2, right? And what was the derivative there? 0. So we're going to put a 0 here. Where's the other x value that has the same situation? 3 pi over 2. Yeah, 3 pi over 2. Good. If I was to draw the tangent line here, it would look like that. So I also have a 0 for slope there. All right, because the table is f prime. All right. So that's the only place I have 0, right? But let's look here. Let me look here. At that blue dot. If I was to draw a tangent line, it would look like that, right? What slope does that red line have? How many rise, how many run? How many do I go up? How many do I go over? Let me draw it better. So start at the blue. How many did I go up? How many did I go over until I hit another? I went a 1, right? I went up 1 unit, over 1 unit. And there's another dot there, right? So what slope does this line have? 1. 1 over 1, which is 1, right? So at 0, I have a slope of 1. Is there anywhere else I would have a slope of 1 from 0 to 2 pi? Close. That would be -1, right? So yeah, here, right, it would be the same situation, right? Just going in the opposite direction. So instead of +1, you would have a slope of -1. So at pi, we're going to have -1. And then where else would we have a +1 tangent line slope? 2 pi, yep, right at the end. 2 pi. 2 pi, I would have the same slope that I did at the beginning. So let's put that in here. So we're not going to fill out all of these boxes, but we're going to fill out enough so that I can see the picture. So I'm going to go make 5 dots. 5 dots on this graph. On the same graph, on top of the same graph, I'm going to go make 5 dots. The first one is at 0, 1, right? So at 0, 1, it's up here. The next one I have is pi over 2, 0. The next one I have is pi -1. The next one I have is 3 pi over 2, 0. And the last one is 2 pi 1. So I'm going to connect the dots. I'm going to use a kind of a dashed line like they did before, and then see what happens. So it's not straight lines because sine and cosine don't have straight lines. They're curves. So let me highlight this in green. So the green is f prime. It represents the derivatives, right? What does the green look like? It looks like cosine, doesn't it? It looks like the one right below it, which is cosine. That's why the derivative of sine is cosine. The derivative of sine is cosine. Because when I graph its derivatives, it looks just like sine. Go ahead. Okay. So let's look at cosine now. What's the derivative of cosine? The answers are at the bottom, but I want to show you why they're answers. I used to just tell students the answer, but then they're like, why is it? That's a great question. Doesn't take very long to answer it, but it's important. Okay, so now we have the cosine wave, right? Looks like the sine wave, just a little different. So again, where would derivatives be 0? Where would derivatives be 0 for this guy? When x is what? So let's see. Let me see here. Let me draw it again. So at pi, right? At pi is one spot, absolutely. So at pi, the tangent line would look like this. So the derivative at pi is 0. Where else? There's actually more on this one. There's actually 3 spots where it would be 0.
When x is 0?
When x is 0, good. And when x is 2 pi. 0, 2 pi. Good. When would this guy have a derivative of positive 1? What x value would it have a derivative of positive 1? 3 pi over 2. That would have a derivative of positive 1, right? And that's the only spot it would have a derivative of positive 1. How about negative 1? Where would it have a derivative of negative 1? Pi over 2, good. I got 5 points, just like I did the last time. Let's sketch it and see what it looks like. 0, 0, make a dot. Done. Pi over 2, negative 1. Pi 0. 3 pi over 2, 1. And then 2 pi 0. Okay, so let me draw a little dashed line here to connect all the dots. Does it look familiar?
No.
Let me draw a different color. Magenta. Does the magenta look a little, does it look familiar? Yeah, it looks like sign flipped, right? The magenta and the yellow up here from the first one, they look very similar. They're just flipped. Like sign goes up, goes down, goes back up. This one goes down, goes up, goes down, right? It's the opposite. It's the opposite. So we would say G prime is the opposite. How do we say opposite? In math, when we say opposite, that usually just means like negative, right? Oops. Right. So cosine, what is cosine's derivative? Not quite sine, it's actually the opposite of sine, negative sine. Negative sine. Okay? So that's 2 of them. I'm going to show you one more and then we'll... So here is the 6 that you're going to see. Okay? Now, the biggest question is, do I have to memorize them? Well, no. Because you're going to use them so much that you'll remember them. Or if you don't remember them, that's what you put on your card. So I wouldn't memorize them. If you don't know them or if you don't remember them, put them on your card when we take a quiz or a test. Okay? So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of a tangent is actually secant squared. The derivative of cotangent is the opposite of cosecant squared, or negative cosecant squared. The derivative of secant is secant times tangent. And the derivative of cosecant is negative cosecant times cotangent. Okay? Now, why is each of them the way they are? Well, I showed you the first 2, right? I showed you why sine and the derivative of sine is cosine, the derivative of cosine is negative sine. I'll show you one more, and then the rest, just take my word for it, because it's not. So I'll prove the last one. The third one on the first column, tangent. So why is the derivative of tangent secant squared? Why is the derivative of tangent secant squared? Okay. So tangent, what's special about tangent? Think about the unit circle, if you can remember that far. Think about the unit circle. What's special about tangent versus sine and cosine? Tangent was different. It was, they were special. What was it? So if you're thinking about the unit circle, right? sine was x over 1, right? Cosine, no wait, was it x or y? I think, no, this was y. Cosine was x over 1. Tangent was a combination of both. It was y over x, y over x. Because sine, opposite, because sine is opposite over hypotenuse, right? And the hypotenuse is always 1 on the unit circle. Cosine is adjacent over hypotenuse. Tangent was a combination. It was opposite over adjacent. So it was y over x. Okay? So, in other words, tangent, isn't tangent the same thing as sine of x over cosine of x? Right? Because if sine is y over 1 and cosine is x over 1, then tangent is sine over cosine, y over x. Okay? So now let's find the derivative of that. To find the derivative of that, we're going to use, starts with a Q, quotient rule. Yep. So find the derivative of this guy. Quotient rule says bottom squared, right? Low times the derivative of the high. What is the derivative of sine? We just found out. Cosine. Minus the high times the derivative of the low. What's the derivative of cosine again? Yep. Minus sine, negative sine, opposite of sine, however you want to say it. Okay, so let's simplify this. Cosine squared of x, because cosine times cosine is cosine squared of x, right? Minus, and then negative sine times negative is be positive, right? Because when I distribute this negative, it's going to be positive. Sine squared of x, right? Over cosine squared of x. Cosine squared of x plus sine squared of x. Does that sound familiar? It's one of the only trig identities you know. It's really the only trig identity you need to know. And it only pops up every once in a blue moon. Yeah, it doesn't pop up a lot. So the only trig identity we use in this class is the Pythagorean, right? Pythagorean. This is x, this is y, that's 1, right? Cosine, we know, isn't Pythagorean theorem a squared plus b squared equals c squared? Well, what's x? I just erased it over there, but what was x? Cosine. What was y? Sine equals 1, right? So do we see any of these things over there? Do we see any of these things over there? Yeah, cosine squared plus sine squared. What is cosine squared plus sine squared equal to? 1. So it's really 1 over cosine squared. And what's the relationship between cosine and secant? The reciprocals of each other. So 1 over cosine squared is actually secant squared. That is why that's proving it. Will you be asked to prove it? No. But the reason why I do it is because every year I didn't do this, I'd have students questioning me. Are you sure that the derivative of tangent is secant squared? Are you sure that this? They would question me. So I'm like, it's a great question. So that's why I threw these on. There's 3 more, but I'm not going to take time to do it. You can look it up if you want to, if you're that curious. If you're that curious about it, if you don't believe me, there are plenty of resources online where you can spend time looking at the proof. Okay? What kind of questions will you be asked? Down here. Find the derivative. The hardest step for doing these problems is the first step. We have 3 rules: power rule, quotient rule, product rule. Which one are we going to use for this guy? Product, yeah. Product and power, yeah. Almost always we use power, but sometimes we'll use product. Why do we use product? That's a great, Damien, why are we using product for this one? You're right.
It's x squared times sine x squared.
Yeah,
Sine.
they're 2 functions, right?
Straight sine.
X squared is its own function. Sine squared is its own function. So if we're multiplying 2 separate functions together, that's product rule. Product rule says, first times the derivative of the second. What's the derivative of sine? Cosine. Plus the reverse. The second times the derivative of the first. Bless you. What's the derivative of x squared? 2x. These 2 are not like terms. So there's nothing you can really, I mean, you can factor out an x. I would just do this. Move the 2x to the front of the sign. They're not like terms, so you can't add them. Yeah, you can factor out an x, but there's really no reason for that. You're done. That's as far as you can simplify. Okay? Okay, let's try the next one.
That's pretty good.
This again.
Cosine of x divided by just regular plain old x. We have division, right? Bless you. Quotient rule. Quotient rule. Bottom squared, low squared. So now the quotient rule says low, which is x, d high times the derivative of cosine. What's the derivative of cosine?
Minus.
Yep, negative sine of x, good. Minus high d low. What's the derivative of x? 1. Okay, clean it up a little bit, simplify as much as you can. There's not a lot to simplify here, but some of the negatives and stuff. So this is really -1, right? So I'm going to move the -1 to the front. So it's going to be -1x times sine of x. And then cosine of x times 1 is just cosine of x. So it's going to be minus cosine of x. All right. All right, let's try the next one. Secant. Okay. Secant, now when they change the letter, it's no longer x, it's t now. So before we do anything with derivatives, I have a root. I don't want roots when I'm doing derivatives. Change it. So really this is t to the 1/2 power plus secant of t. So do I have to use product rule, quotient rule for this one, or can I just get away with using power rule for this one? Yeah, just power rule, because there's a plus in the middle. It's not a multiplication, it's not a division, it's just a plus. So I'm just going to find the derivative of t to the 1/2. Move the old power to the front. Subtract 1 whole from the old power. You get negative 1/2, right? What's the derivative of secant?
Secant tan.
Secant tan, right? Secant t times tan of t. So last step, put everything kind of back. So you would get t, or 1/2. It's negative, it's a negative power, right? So a negative power means it's got to go to the bottom because it was at the top. 1/2 means square root, so it would be that plus, this guy is just secant t times tangent t. I know it's like wrong or to have a root at the bottom, but in this class we don't really worry about that. Roots on the bottom are okay. Yeah. They teach you all the way up to Math 3. You can't have a root on the bottom. But then you get to this class and it's okay. It's not a priority in this class. Okay. All right. So what do we got left? We got 2 left. 2 left. Oh, we got plenty of time. Okay.
Oh my god, these numbers.
No, we found the numbers.
You finally have numbers. Oh my god.
H of S. So now S is our X. If you don't like H of S, just put H of X. It's okay to change it that way, as long as you rewrite it like that. Okay, so a couple things here. For this guy here, do we have to use quotient rule for this guy? Can you use quotient rule? Yes. But here's a little word of advice. Try to avoid it. Yeah, it becomes, you guys have used quotient rule. It becomes a more difficult thing, right? So when you don't have to use quotient rule, try to avoid it. There's sometimes you can't avoid it. But this one we actually can. How can I avoid using quotient rule for 1 over s? Is there a way I can change it?
Power.
Yeah, power rule. How can I write it with a power instead of a fraction? -1, s to the -1 power. I would suggest doing that and using power rule. Could you use quotient rule and get away with it? Absolutely. But quotient rule is just, it's only something we want to use when we have to. Okay, and then I have this, the green part. Do I use quotient or a product rule? Do I have to use the product rule for the green? No, good. This is one of the hardest things for students to get a handle on. They think because you're multiplying here, you have to use the product rule. No, why not? Why can't I just use power rule for this?
Because 10 is the coefficient.
There you go. 10 is just a coefficient. It's a number. If it was -10x, product rule. -10y, product rule. But it's just -10, so you don't have to use the product rule, or product rule. Okay. Okay, so let's do the first part, the yellow part. So, derivative. The derivative of s to the -1, move the old power to the front, times s, subtract a power, so we would get -2, right? -10, that's just a coefficient, so leave it like that. What's the derivative of cosecant?
Negative cosecant times cotangent.
There you go, yeah. It's right here at the bottom of the first page. Negative cosecant times cotangent. So we're going to write negative cosecant of s times cotangent of s. Okay, that's the calculus part. Now we got to kind of clean it up. We got some double negatives here. We got some negative powers here. So this guy is going to become this. And then I'm multiplying this times this, right? Because there's a -1 there. So it's actually going to be plus 10 times cosecant of s times cotangent of s. Okay. So only use the rules when you need to, especially the quotient rule, because quotient is a whole thing. Quotient rule is a whole thing. Product rule, not so bad. But quotient rule involves a lot of other parts and stuff that if we don't have to, don't do it. But when you have to, do it. Okay. This one doesn't have any fractions or anything like that, so we're good there. It's multiplication, x times cotangent of x. So we don't need to change anything. Which rule are we going to use here? Product rule. So first times the derivative of the second. So go back to your sheet, the beginning, the first one, or sorry, the bottom of the first page. What is the derivative of cotangent?
Negative cosecant squared.
Yep. Negative cosecant squared of x plus. All right, so now we did the first times the derivative of the second. Now we're going to do the second times the derivative of the first. Well, what is the derivative of the first guy? What? Okay. Okay. So we got -1 times x, so we get -1x times cosecant squared of x plus cotangent of x. Okay. All right, since we got time, I'm going to give you some problems that I didn't get a chance to put on there, just for extra practice. Let's see. Okay, so we'll call this F.
Oh boy.
So 2 problems I want to give you, and there's a reason why I want to give you both of them. Y equals x times sine of x plus cosine of x. There's the first one.
I gotta write it like how they would write it.
Okay. The reason I'm giving you this one is because it's a combination. We have to use a couple different rules. So the first thing is we have this term. That's the term here. That's a first term. And then here's the second term. So we got to do them separately. The yellow first. So if I'm doing the yellow, if I'm finding the derivative of the yellow, what rule do I have to use? Product, because x is not a coefficient, x is a variable. So we have to use a product rule. So I'm going to use the product rule first. So the first times the derivative of the second, derivative of sine is cosine, plus the second times the derivative of the first. That's the derivative of the yellow. Haven't done the green yet. The green is just cosine. It's not times anything. There's nothing in front of the green, in between the green and the plus sign. So it's just cosine. The derivative of cosine is sine. So let's clean it up. So we got x. Yo, sorry, yeah, you're right. Sorry, thank you. There we go. Plus sine of x minus sine of x. Can I? So I'm not telling you yes or no. I'm just saying, can I? Can I say, hey, this is sine. This is negative sine. Boom, boom. Get rid of them.
Yes.
Yes, I can. Absolutely.
I don't think so. That might work.
So you're just left with x times cosine of x. Okay, so in lieu of a last problem, I want to show you something. I'm not going to give you another problem, but I want to show you.
Oh,
So sine and cosine. Sine and cosine are very much related. Sine and cosine are, they go together. They look similar. Their waves look similar, right? So I'm going to show you something I've shown in my last class. Okay, so if you start with sine. What's the derivative of sine? We just learned it. Cosine. What's the derivative of cosine?
minus.
Minus sine.
Minus cosine.
No, oh my god.
What's the derivative of negative sine? It's not on there.
Minus cosine.
Minus cosine, right? Isn't the derivative of sine cosine?
Oh no.
That times 1, right?
Oh no.
So it's negative cosine.
And
And what's the derivative of cosine? Negative cosine.
Sine.
Oh my god.
I know.
What?
Guys, it's a circle.
Wait, I would write this down.
I all over again.
So the reason I'm telling you this, is because you will see problems where it says they want you to find the sixth derivative of
Oh, it's I.
It's I all over.
of sine.
It's always I.
What's the sixth derivative of sine? Well, 1, 2, 3, 4, you know.
5, 6.
It's a circle. It's a cycle.
Cosine.
It's I all over again.
It's I.
Okay?
It always comes back. I always come back.
So I always, even when I'm doing these problems and they're asking me for like second derivatives, third derivatives, fourth derivatives sometimes,
Find it.
anytime they ask for first, second, third, fourth, fifth, sixth derivatives, anytime they ask for any of those, it's going to be sine or cosine. Okay? It's always going to be sine or cosine because they know. Can you do the fourth derivative of tangent? Yeah, but I mean, that would take, they know it takes a long time. They want to know if you know the pattern. Okay? All right. I saw that only one person has submitted